like not focusing.
Top, bottom.
It's gonna fall. You can't.
Try again. The top of our reflex template is our input. The bottom where we're doing output, right? We're solving things with our endocrine system. That's why our hypothalamus can be our starting point, because our central nervous system has already gotten that top part information and decided, whoops, we need to make some sort of physiological change. We need to utilize the bottom part. In this case, we're going to do it with our endocrine system. So what we are going to do now is put the details for that bottom part of our reflex template as it is utilized by our endocrine system the majority of the time. Notice there are, I said just the majority of the time, as there are exceptions to this in how the endocrine system works, but for the vast majority of what we'll work with, this is the overall steps and plans for how it happens. So we've got that ignorant information, something is off, so we need to solve it. So neurotransmitters, endocrines, starting this, and we know our starting place from yesterday, where we can switch from being the nervous system to getting the endocrine system activated is our hypothalamus. Our hypothalamus, to start our endocrine system, isn't going to release a neurotransmitter, it's going to release a what? That wasn't a hard question. We're talking about the what system now? Endocrine. So what is our hypothalamus going to release? An endocrine. Right? It'll make sense in a moment, but we are always going to call the endocrines that are made and released by our hypothalamus endocrine 1. So when we talk about endocrine 1s, we know we're talking about something coming from the hypothalamus. Where is our endocrine 1 going to go to? From yesterday, we know the hypothalamus talks to the pituitary gland. What's the other name for the pituitary gland, the fancier one? The hypophysis, exactly. And we know that it's going to go through the portal vasculature system. And yes, we talked about 2 different ways, but remember we had 7 endocrines following to go to the anterior and only 2 to the posterior. We're going to follow that anterior pathway. So this endocrine 1 is going to go through that portal vasculature. It's inside, what's that connective tissue called that we learned yesterday? It's a fun name. The infundibulum. To get to our anterior pituitary gland, bind to receptors there, so that our anterior pituitary then is going to release what? A neurotransmitter, right? A paracrine? What's it going to release? Yeah, an endocrine. So that wasn't going to be a hard question. It's the second in our series. See why I said it would make sense why we called the first one endocrine 1 before. Endocrine 1 is going to get us endocrine 2 to be released by our anterior pituitary gland. That endocrine is going to go out in our wide circulation, but it's not typically going to do jobs itself, although we'll see one endocrine that does. One should be more precise, there's one endocrine 2 that does. But it is going to go to another location. It's going to go to a particular gland. Here for our figure 100, that gland is our, does anybody know what that picture is of? Our adrenal gland that sits atop our kidneys, yes. But we got a variety of glands that, depending on what our endocrine 2 is, it's going to go to a specific gland. And then that gland has the receptors for that endocrine 2, and guess what that gland is going to release? Endocrine! We finally got the pattern. And what are we going to call this and get our physiological change to happen. So, our bottom of our reflex template, which was just afferent pathway to our effector. Well, we're effector all the way down there. See how detailed that efferent pathway, did I just say afferent? How detailed that efferent pathway is when we're talking about our endocrine system. So, gets us to our physiological effect. So we can see from our basic template that we worked on back in January, we took one little arrow and turned it into all these steps when we're talking about our endocrine system. So, thinking about this, one thing that we need to note about this endocrine 3 is, yes, it has this first job of, hey, go to those effectors, get our change to happen. But conveniently enough, it's the third one in the order, so we call it endocrine 3. And I say conveniently enough because guess how many jobs it has? 3 also. Nice, easy to remember. But wait a second, isn't it one job just to get our effects? What did we say was the big thing that was going to be new and different about our endocrine system yesterday? Nobody wants to participate this morning, it's just too hot. I'm just going to keep moving faster to generate my own coolness. So, we need to do negative feedback. We know that these endocrines, when they're in the blood, they're going to have this long-lasting time, unlike our neurotransmitters that we can clean up really quickly with an enzyme. Not so easy when they're spread out through your entire body. So the other 2 jobs are, uniquely enough, to do negative feedback on their own production. So, our anterior pituitary gland has receptors in it for this endocrine 3, and when that endocrine 3 binds to those receptors, guess what it does? Stops releasing endocrine 2. Negative feedback on its own production. And the same thing with the hypothalamus. So those other 2 jobs to make our 3 jobs, gets our physiological effects. Jobs 2 and 3 are to do negative feedback on its own production to say, hey, you got me made, I'm out here. You don't need to make more of me. I'll get the job done. Not something that we saw in regards to our nervous system and what our neurons do. So, we need to remember this. 3 jobs for our endocrine 3. So, what we end up seeing as a result of this template that we will use for the rest of our endocrine system, we need to know it. You can see that it is self-regulated by that endocrine 3 with those additional 2 jobs that it has, doing negative feedback on its own production. Why are we making it so difficult? Right? Why not just have endocrine 1 go and get our physiological effects to happen and not make me have to learn all the other stuff? Right? Wouldn't that be a lot easier? No? It would. So if we're making it more difficult, more steps, there must be some benefit to that. Some reason why a one-step process is not as good as a multiple-step process. Well, the first benefit is when we have more steps, we have more opportunities to impact the process. It's okay, you don't need to phone a friend about it. I need to check you on it. That's what we have. A good benefit happening. It also gives us the opportunity to create a lot more paths, which you have in that PDF that you, in some way, brought to class today. The second one is amplification. We saw amplification previously when we were talking about our membrane-bound receptors and the fact that if we involved an enzyme in the process, we could go from one ligand to many responses. So, not talking about that in regards to this, but an amplification, an expansion going out. Well, let's think about it. If we took this to the simple stage and just had endocrine 1 get us our physiological effects. If we want more physiological effects, what are we going to need? More endocrine 1 made. If we need more endocrine 1 made, we're going to need more cells devoted to making endocrine 1, right? What's going to happen to our hypothalamus in that situation? It's going to get bigger. If we want more of it to do things, we're going to need more of it to create those things. Point to where your hypothalamus is in your body. Is that a limited space? Yes. If we start expanding your hypothalamus, something else up there in that confined space of your skull is going to lose out on space. Is that going to be a problem? Yeah, we got everything packed in there. So we can't produce a whole lot of endocrine 1s, because that would mean a bigger production plant, and we're already space limited. Oh, so let's keep a small number of endocrine 1s, but then expand on our endocrine 2s. Where's our endocrine 2s produced? Pituitary gland, point to that. Oh, it's also in that space-limited area. Actually, individuals who have problems with their pituitary glands, where they do grow too large, they usually learn that not because of the pituitary gland doing things, but because of the loss of function by it taking space away from other areas of the brain. And then realizing why those areas are having problems and go, oh, it's because the pituitary gland expanded. So we can't make the pituitary gland bigger. Oh, that's why we need to have this complex system. Where are our glands? Where is, in this picture, our point to your, you guys know where your kidneys are? And therefore, yeah, lower back. Can we expand the size of your adrenal gland? Yeah. Can we expand the size of your liver? Yeah. So when we move outside of a space-limited area, yes, we're going to see extreme situations where things get issues if we expand those glands too much. Outside of our CNS at our gland spot than we do in the space that our CNS is, which the first two categories are. Is everybody clear on that concept? Alright. So, what you hopefully have realized is that by utilizing this template, we're effectively going to be working with quartets. 4 things. 3 endocrines, conveniently named endocrine 1, endocrine 2, and endocrine 3. And then we also have to name a gland. I can see a few of you were like, wait, no, we got 6 things. We also have the hypothalamus and the pituitary gland. Except we don't have, there's nothing changing there because it's always the hypothalamus releasing endocrine 1. It's always the pituitary gland anterior releasing endocrine 2. It's just what gland is releasing endocrine 3 that's variable. So we got 4 things that are changeable. But the cool thing is, if we name any one of those 4, they're only a part of one fluid from our hypothalamus. The first tab in is our pituitary gland, second in our cortex, that endocrine tube. Then we have to name the gland, that's our third one, and then we name our endocrine 3. So you can see that right there in that file that I gave you. So, talking about that, let's go through those. And why you now don't have to write down the components, the names that are on the slide. You have them in hand. So, let's look at those 7 that are endocrine ones coming from our hypothalamus, going to our anterior pituitary gland, following that one of 2 pathways that we talked about yesterday to get to our pituitary gland. They're referred to as hypophysiotrophic because the hypothesis, first part of that word, and we're causing something to happen, be made there, the trophic part. So actually, if you do medical terminology, it actually is a meaningful name. So, cool thing is we can subdivide these 7 because only 5 of them are stimulatory to that anterior pituitary gland. Do what we've been talking about and cause an endocrine 2 to be released. So let's look at these 5 first. First one, thyrotropin releasing hormone, is our endocrine 1. What does it go to our anterior pituitary gland and cause to be released? Thyroid stimulating hormone. Right now, we're just focusing on what is our endocrine 1 that goes with then to our endocrine 2. But we can also, hopefully, to a person in this room, deduce at least what the third part of our quartet is. What's our gland going to be in this situation? Thyroid gland. Nicely enough, the names are, as I said, all term long that I like. The names are helpful in these situations. Now, another thing we can see is we got some historic baggage. If hormone gets used a lot, it hasn't been replaced with endocrine because people don't want to change those. But so they get used with the hormone name. Now, you might be saying, whoa, that's a whole lot of words for me to remember. Editorial side note, I will, on any assessment, when I'm talking about an endocrine, give the abbreviation standard for it. So this is TRH is our endocrine 1 that gives rise to TSH. So yes, you can learn them by their acronyms. However, if you don't understand what those acronyms mean, it's very easy to flip them around and say, oh, TSH, TRH, TSH must go first. If you don't understand what the underlying letters mean, right? So be careful. Students on the inside, give you both options. You can decide what you want to do, but I'm just telling you the warning. So, our first pair. Our second pair, corticotropin releasing hormone, is our endocrine 1. Our endocrine 2 is adrenocorticotropic hormone. CRH gives rise to ACTH. Our third pairing of endocrine 1s to endocrine 2s, growth hormone releasing hormone. Please, nobody ever mess this one up. Gives our endocrine 2 of growth hormone. Please see why I can say, please don't mess this one up. Right? GHRH gives rise to GH. So we got 3 out of our 5. Our other 2 are a little bit different. So, what's different about our number 4? Yes, I hear the whispers. She's going fast, but I can't write down these names. Why do I not worry about you not being able to write down these names? Because you already got them on the sheet that I gave you. So, gonadotropin releasing hormone. GnRH, gonads. ones first before we start to see something odd. This one is atypical because it actually causes our anterior pituitary gland not to release one endocrine tube, but to release two endocrine tubes. Follicle-stimulating hormone and luteinizing hormone. So G, and yes, that's a classic abbreviation for it with a little n. RH gives rise to FSH and LH. One E1 gives us two E2s. It's also unique in that this is the one system in our body that's actually female biased in its name. Everything else is more male biased. So, little fact. Talk about that more when we talk about the reproductive system at the end of the term. Our last one is different because of its name. Everything else, our endocrine one, is ended with releasing hormone. This one, you'll see it either as prolactin-releasing peptide or factor. Really is kind of evenly split across the textbooks if they're not also, like I am, telling you both names. Why is this one named different? Because guess what? It was discovered after we changed over from calling them hormones to calling them endocrines. So it didn't get that old name of having hormone with it. Didn't want to call them a releasing hormone. So releasing peptide lets us know what type it is. That's why individuals like that name. Factor is just helping us do something. What is it doing as far as an endocrine tube? It's causing our anterior pituitary gland to release prolactin. So those are our 5 endocrine ones that cause an endocrine tube to be released. But we know 5 plus 2 gives us 7, so we're missing 2 that don't stimulate. Therefore, they must do what? Inhibit is a reasonable guess, yes? They're going to inhibit. They're actually going to go to our anterior pituitary gland and say, nope, please stop releasing a particular endocrine tube. First one in this category is somatostatin. This is not a very helpful name to let us know kind of what quartet it's impacted. On your sheet, it is present with its quartet that it impacts, but it's italicized in there saying that it's to indicate that it is hidden. So, there's a big push and a rather successful push that maybe when you guys end up teaching this class, you won't be talking about somatostatin, or you'll be talking about the other name first, is to give it and use its more useful name and to call it growth hormone inhibiting hormone. So what might be our endocrine tube that's going to get negatively impacted? Growth hormone. So, growth hormone inhibiting hormone, somatostatin, takes down the level of growth hormone. And when we talk about how your growth works, we'll see why we need to have the hypothalamus helping out with the negative feedback. Second one in this category, final one in our overall, things that are going to our anterior pituitary gland, is dopamine. Yes, we've seen that a couple of times already as categorizations. We saw it as a neurotransmitter. Talked about what it did there a little bit. dopamine is used in so many other places, to name it physiologically based on one job, not as helpful in my book. So, dopamine, its alternative name, is prolactin inhibiting hormone. We can see how that's so helpful because that tells us what's our endocrine 2 that's getting lower. Yeah, it's our prolactin. And when we talk about reproduction, we can talk then about why, like with the growth situation, we need an alternate pathway to lower down prolactin's levels. So, details as to why we need these later. Those are our 7 endocrine ones that are released, going through that portovasculature to reach our anterior pituitary gland. 5, getting a release of an endocrine 2, 2, dropping down the level of release of an endocrine 2. So let's move down our template for our endocrine system. We've seen endocrine 2s. Where do those endocrine 2s go as a gland? And what does that gland release? So finishing out our cortex. Let's go back to where we started. We started with TRH giving rise to TSH. So we're looking at that endocrine 2, TSH. We already figured out what the next step in our quartet is. What's the gland? Thyroid gland. And we can already, based on what we know, and actually I've mentioned again today, what do we know is going to be released by our thyroid gland? T3 and T4. I said yesterday the reason for that T is it's representing the thyroid. So it actually causes the release of 2 endocrine 3s. Not a big deal, right? It's a little off of our basic template, but no big problem. We saw a quirk in that sense in our endocrine 2 with our gonadotropin releasing hormone. Second one was ACTH from our CRH. Let's see, we had corticotropin releasing hormone. We had adrenal in as our A for our ACTH. Can anybody guess what gland we're talking about here? Our adrenal gland. This is actually the one that is in our picture, our figure 100. This is going to our adrenal cortex. Because we know our adrenal medulla is our postganglionic neurons of our sympathetic nervous system. So it's the outer part of our adrenal gland, the cortex, that is the glandular component. And what are we going to get for endocrine 3? The generic name is corticosteroids. We're going to talk about it as a name that I'm sure to a person you have heard of, cortisol. Right? We're going to see cortisol's impact on the body. Growth hormone wasn't unusual in its 1-2 situation, but it's interesting in its 2 after situation. So it does follow our normal template, and then we're looking at liver as our gland. Why do I have plus? Because there's actually another spot that acts as a gland component, but we'll talk about that when we do growth next week. So right now I want to keep it as our template. So liver as our gland, that's easy for you to wrap your brains around. And then what's our endocrine 3? IGF-1. Insulin-like growth factor is the big expanded name. But in terms of physiology circles, this is a whole lot like in biology circles, say in DNA. That we rarely ever use the full name, we just use the acronym. When we're talking about IGFs, we typically don't say insulin-like growth factor 1, we just say IGF-1. So that's why usually I have the abbreviation afterwards, that's why I have them flipped in this situation. But that seems totally normal. Why did she say that this one's a little weird? Well, remember I said when we were doing our basic move through our template then our endocrine 2 goes out to some gland and gets an endocrine 3 made. Typically. Here's the one oddball. Growth hormone actually is the one endocrine 2 that has the ability to go and bind to many tissues have receptors for growth hormone itself. And consequently, when those receptors get bound by growth hormone, we see growth of those tissues. So oddball in that our endocrine 2 can actually get results, physiological changes to happen. Our fourth one is actually our fifth one also, because we know that they both are coming from our anterior pituitary gland receiving what? What's our endocrine 1 for FSH and LH? GnRH, exactly. Both of these impact the gonads, hence why it's gonadotropin releasing hormone. So they're both going to go to the gonads. Depends on the individual's development as to whether they have testes or whether they have ovaries that these are going to. We're just going to leave it as the generic since we got two options. Talk about sex at the end of the term. But we're just going to have the sex endocrines being made. You can think of that sort of poster child testosterone coming out of the testes and poster child estrogen coming out of the ovaries. But we got this added feature for follicle stimulating hormone, and that it is the reason why we are able to produce our gametes. Our sperm, our egg, happens as a result of FSH creating follicles that house those components for us in the testes or the ovaries. So, those components. We also know that we had our endocrine 2 of prolactin. Anybody figure out from the prolactin name what lactic? So what are we talking about? Going to produce milk, right? Lactate. So these are going out to the mammary glands and going to cause those mammary glands to produce milk and also to increase the size of the mammary tissue so that we can produce more milk. Seems like we should be done talking about our cortex, but we actually know that we have two more. We see them in our circulation, beta-lipotropin and beta-endorphin. Why did we not talk about an endocrine 1? Because we don't know what it is. Why did we not talk about what's its consequences? Actually, in terms of humans, these are two pathways that currently we are not utilizing. But the names are incredibly helpful. And I'm going to put that as something that